Hello, everyone. Today we are taking notes on angle of elevation and angle of depression. So, many real-world problems that involve looking up at an object can be described as an angle of elevation, which is the angle between the observer's line of sight and the horizontal line. So, the horizontal line is always looking straight ahead. When I tilt my head up, this angle that I create here is the angle of elevation. So this angle right here is the angle of elevation. Now we can have the same thing when someone's looking down. That is called the angle of depression. It's between the observer's original line of sight, so the horizontal line from the person looking straight ahead, and where they look down to. So that is the angle of depression. Now, a cool thing about this is the angle of elevation is always equal to the angle of depression because those lines are parallel, the two horizontals. So these two angles will always be equal. So let's see how to use this. So the angle of elevation to an airplane viewed from a car at an airport is 7 degrees. So if we have the car, there's my car, and it's looking forward, we look up. This angle right here is 7 degrees. The pilot reports that the altitude is 5,200. So our plane, I can't draw, there's our plane, is 5,200 feet above the ground. We always measure altitude at a right angle. How far from the car is the airplane? Now, when we're talking about how far away from the car is the airplane, we're talking about this distance down here, not the actual vertical line, but this one down here, because it's really how far below. So we're looking for x. So we need to remember our ratios. So remember, sine is always opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So when our angle is down here is 7, the 1500 is opposite, and the value we're looking for is adjacent. So that means we're going to use tangent. So we say tangent of 7 equals 5,200 over x. So to solve that, remember we put tangent of 7 over 1. We cross multiply, so we get x tangent of 7 equals 5,200. We need to get x by itself, so we divide by the tangent of 7. And so on our calculator, we're going to do 5,200 over tangent of 7. We're going to round to the nearest foot. So that gives us, when we round to the nearest foot, 42,351 feet. So number 2. Maria is on top of a cliff. So here's Maria up here. Sees a seal in the water. So here's my water, and over here's my seal. The cliff is 40 feet above the water. And the angle of depression is 52 degrees. So remember, our angle of depression goes from the horizontal looking down. But also remember that our angle of depression is always equal to our angle of elevation. So if we were the seal looking up at Maria, that would also be 52 degrees. What is the horizontal distance from the seal to the cliff? So again, that's this distance down here, which is x. So now that I helped you draw the picture, I want you to pause and find out how far away the seal is. Okay, so reminder, we have SOHCAHTOA, which means sine is opposite over hypotenuse, CA, which is cosine, is adjacent over hypotenuse, and tangent is opposite over adjacent. From our 52, 40 is opposite and x is adjacent. So we can say tangent of 52 is 40 over x, put tangent of 52 over 1, and cross multiply. So x tangent of 52 equals 40. To get x alone, we divide both sides by tangent of 52. Chromebook was being weird there for a minute. Sorry about that. We do that on our calculator. And when I round to the nearest foot, it's 31 feet. Okay, so number 3. The student can see the water tower from the closest point of the soccer field. So here's our student. And they can see the water tower. The edge of the soccer field is about 110 feet away from the base of the water tower. So here's my water tower. This is 110 feet. Stands at a height of 32.5 feet. What is the angle of elevation if the eye level of the student viewing the tower from the edge of the soccer field is 6 feet above? So here we're going up 6 feet, and we're looking for this angle of elevation. So we're looking for the angle. So first of all, how does that 6 feet matter? Well, what that 6 feet does is that changes my right triangle to be this purple right triangle. Where instead of being 32 feet, this purple part is 32.5 minus 6, so it's 26.5. Now using that purple triangle, we're looking for x again, so that 26.5 is still opposite. 110 is adjacent. So again, using our SOHCAHTOA, that tells us we're using tangent. So it's the tangent of x equals 26.5 over 110. Remember, when we're trying to find an angle, that's when we use our inverse operation. So x equals tangent to the negative 1 of 26.5 over 110. And reminder, how we get tangent to negative 1 is we do second tangent and then our fraction. And they asked me for it to the nearest tenth. So x is 13.5 degrees. Okay, last problem for today. As shown in the diagram below, the angle of elevation from the point on the ground to the top of the tree is 34 degrees. If the point is 20 feet from the base, what is the height of the tree to the nearest foot? So we're looking for x. So here's my angle. So x is opposite, 20 is adjacent because the hypotenuse is always across from our right angle. So again, the ratio with opposite and adjacent is tangent. So it's tangent of 34 equals x over 20. Put tangent of 34 over 1. We cross multiply. So it's 20 tangent of 34 equals x. We do that on our calculator, rounded to the nearest foot, nearest tenth of a foot, it's 13.5. So that's the end of the video for today. If you have any questions, please ask me in class the next time I'm there.